Good day everybody, welcome to my video lessons. Today's lesson will be on using trigonometric identity to integrate certain trig function. So far we have covered the 6 basic trig function that we can integrate straight away using the formula. But there will be other trig function that cannot be integrated using that 6 basic formula because it doesn't cover all trig function. So we're going to look at it. We're going to look at 3 types of identity where you can use to integrate a certain type of trig function. Okay, let's take a look at the topic. So our topic is using trigonometric identity to integrate. So these are the identities we are looking at. So if you come across sine square, cos square, tangent square, or product of sine and cos with the same angle, then we can use this identity to integrate. So if we come across sine square, then we use the double angle identity, which is this 1 minus cos 2a. Remember, it's a double angle identity, so the angle is double from the original. And this one is 1 plus cos 2a. For tangent square, we use the Pythagorean identity, which is secant square a minus 1. For sine a cos a, we use the double angle identity also, which is half sine 2a. See, the angles are double. So these are the 4 basic identities that you need to remember to integrate functions involving sine square, cos square, tangent square, sine a cos a. Alright, let's look at a few examples to get an idea how to apply this. Okay, for the first 6 examples, I will go through thoroughly with you how to go about integrating it. So for this sine square, we use the double angle formula, half into 1 minus cos, double the angle becomes 6x. Integrating will give us half x minus sine 6x over 6. So the idea of using the identity is to change it into one of the 6 forms that we have learned earlier on. Okay, for the next one, also using double angle identity, this will be 1 plus cos, double the angle 2x becomes 4x. Integrating will give us this answer. Integrate 1 will give us x, integrate cos will give us sine 4x over 4 plus c. For the next one, tangent square, we need to use a Pythagorean identity. That means we're going to change tangent square to secant square x minus 1. Integrating secant square is just tangent. Integrate 1 is just x plus c. Similarly, if the angle is different, then we still preserve the angle using the Pythagorean identity. So the angle is still x over 2. Integrating will give us 2 tangent x minus x plus c. For cos square, the angle is a bit different from the other one, but we still double the angle. So half integral 1 plus cos 4x over 3 dx. Integrating will give us 1 will give us x, cos will give us 3/4 cos 4x over 3 plus c. And then example 6, notice it's the product of sine and cos, so that was the last identity we covered. So we're going to change it to half sine 2x dx. That gives us cos 2x over 2 times half becomes 1/4 plus c. Remember the term starting with c, so there's negative sign. So that finishes the first 6 examples. For the next 6 examples, next 5 examples, I will need you to try it out yourself. Pause the video and solve the question. Once you're finished, then you can play the video again and you'll be able to see how the answers are derived. So go ahead and pause the video and start doing the question now. Okay, now I will continue with the answers. So using double angle identity, we have 1 minus cos, double the angle become 3x. Integrating will give me half x minus sine 3x over 3 plus c. Similarly for this one, double the angle again. Integrating gives us x plus 3/4 sine 4x over 3 plus c. For this, we need to expand it first before we integrate. So that gives us 4 sine square x plus cos square x plus the middle term 4 sine x cos x. So we can see here, even for all the sine and cos we use double angle. Similarly, product of sine and cos we use the last identity we covered just now. So let's change this. This one becomes half, becomes 2. 1 minus cos 2x. And this one becomes half 1 plus cos 2x. And the last one is just 2 sine 2x dx. Integrating this will give us, let's do it here. Probably have to erase that. Okay, that will give us 2.5 is 5 over 2, so we'll have 5 over 2x. Integrating cos will give us 2 cos minus 2 cos, but half is 3 over 2. So minus 3 over 2, 3 over 4 sine 2x plus minus cos 2x plus c. So that's the final answer. We will erase example 10 because there's not enough space there, and continue with the next example. We're going to change the next example to be example 10. Alright. Okay, let's do this. So same thing here, we need to expand it first. That will give us tangent square. That will give us secant square 2. That will also give us the middle term 2 secant tangent. Alright, integrating. Before we can tangent square, we cannot integrate straight away. We need to use identity. Secant square we can. Secant tangent we can do it straight away. Okay, replacing it, tangent 2 square 2x is secant square 2x minus 1. Add with this, become 2 secant square 2x minus 1 plus 2 secant tangent. Integrating this will give us tangent 2x minus x plus secant 2x plus c. That's all the 10 questions that I'm willing to go through for this part of the lesson. So that's all for today. Thank you for your attention. Goodbye.